In front of me is a giant metal square, and I'm going to use this as a kind of blank piece of graph paper to plot a random distribution of couscous. Okay, there we go. It's a scatter plot. Okay, maybe not. Now, this is a pretty random distribution of couscous, but when I take my bow and I play this metal square like an instrument, this random distribution will suddenly become decidedly unrandom. Here we go. Okay, this is called a Chladni figure, and there are a few different Chladni figures that I'm able to make with this plate, and I'll show you a few more of those later on in the video. Chladni figures were discovered by someone called Ernst Chladni. But although he discovered that you could make these shapes, he wasn't able to work out the mathematics that describes why the couscous goes where it goes. In fact, he used sand, not couscous, but I found that couscous works a lot better. Uncooked. If you're going to try this at home. The mathematics of where the couscous goes is actually a really hard problem. And most of the work in solving that problem was done by a mathematician called Sophie Germain. Sadly, she got almost no recognition while she was alive for her mathematical achievements. Things did get better, unfortunately, after she died. Another famous mathematician, Gauss, declared, "We must give this woman a posthumous degree." So things improved a little bit. To work out where the couscous goes, Sophie Germain had to work out how the plate moves when it's bowed. And this is a problem of wave dynamics. And wave dynamics is a subject that permeates almost all of physics, so it's hugely important. The equations that describe the motion of this plate are here, or at least these equations describe some of the possible motions of this plate. If you put those equations into Excel, you start to see some of the structure there. And then if you do 3D plots, there you go, you can really start to see it. But if we animate it, there we go. That is how the plate moves when you bow it, or at least in this particular situation, this is what's happening. And you can see the parts of the plate that aren't moving. And that's really important. If you look at the plate here, the parts that are moving jiggle the couscous around, and they move around until they reach parts of the plate that aren't moving. When they get there, they settle and they don't move. So the couscous is marking the places on the plate that aren't moving. You may have seen Chladni figures before, but you probably saw it with a smaller plate that was being driven by a vibration generator to produce the different frequencies that produce the different patterns. But this is how Chladni originally did it, with a fixed plate and a bow. So I'm going to see if I can produce some more of the patterns. The first thing I need to do is apply my couscous randomization function. Okay, here we go. Nice. A big thank you to the Centre for Life in Newcastle for lending me their Chladni plate. The Centre for Life is an amazing science centre run by amazing people, so go and check it out.